To begin with, we're going to talk about the concept of the function. Now, a function is an idea that's going to follow us throughout this entire course, and you could really say that it's what this course is really all about. So we're going to talk about, first of all, what a function is in this video. We're going to talk about a particular class of functions called one-to-one functions, and then finally we'll talk about functions in the context of application problems. So those are kind of the three main goals we have for this video. So first off, what is a function? Before giving kind of a formal definition of this, I would suggest that we think about functions as machines. And let's start with a real simple machine that we encounter all the time, which is the scanner that we see at the grocery store. Okay, so we want to think of the idea of a function like our scanner at the grocery store. So what does this thing do? It takes the items that we're going to purchase, we slide those across the scanner, and then it spits out something to us, right? It spits out the price that we're going to have to pay for that particular item. So to put this in the language that we're going to be using in this course, we think of the items as the inputs of the function. So you're always inputting the information about your item into this function that we call our grocery store scanner, and then it's going to spit out to us an output, which of course are the prices. Okay, so with that idea in mind, let's go back up here to the definition. So it says that a function is a rule for a relationship between an input or an independent quantity and an output or the dependent quantity, in which each input value determines one output value. Okay, so that's the formal definition of a function. So it has to have this property that that the function, every input determines only one output. Okay, now if we think of this in the grocery store scanner analogy, it's pretty easy to understand. What this is saying is that if you give me an input, let's say you give me a particular size Snickers candy bar, then when I scan that particular single input, I better only get one price out. Okay, it wouldn't make any sense to scan the Snickers bar once and have it be $1 and then scan it again and have it be $1.50, right? We would complain to the store that the scanner's broken, right? Because we know that the exact same item should always give the exact same price. Okay, and really that's going to be true of any machine that you're talking about, is that every input you put into the machine, the same thing better happen in the output every time you put that same thing in. Okay, so so that's what a function is. Okay, and so if you did have a situation where you scan the same item twice and the scanner spits out two different prices, then you would say, oh, this particular scanner is not a working machine, and therefore it's also not a function. All right, then one last definition down at the bottom here says that sometimes in a relationship, each input corresponds to only one output, and every output corresponds to exactly one input. Okay, we call this kind of relationship one-to-one, or it's a one-to-one function. Okay, so this is a special type of function in which every single output only goes with one input. So in our grocery store analogy, that would be like saying that no two items in the store have the same price, right? So in other words, if I'm thinking of the number $3.12, only one item in the store would be $3.12. Now, that's not the case in grocery stores, so I think it's safe to say that a grocery store scanner is not going to be a one-to-one function. Okay, so this is just this other definition that we'll take a look at, and I think it'll be a little easier in our next example here, where we explore this a little bit further. All right, so we're going to look at some graphs. And what we want to do with these graphs is we want to first decide, is this graph representative of a function? And then secondly, if it is it also a one-to-one function? All right, so first of all, whenever we're looking at graphs, you're all used to the idea of putting the x values on the horizontal axis and the y values on the vertical axis. So when we talk about functions, in this course, we're always going to talk about them in the sense that the function value is the y value. Okay, so the function value is the y value. Or perhaps an even more clear way to put this would be to say x is the input and y is the output. Okay, x is the input, y is the output. So we're always going to think of it in that way. Okay. So one other thing that we'll discuss here is that when we look at what we call function notation, this is the way we look at it. It's we would say that y is a function of x, and the way we notate that is to put a little f for the function name, although we can use other letters, and then in parentheses we put the input x. Okay, so this isn't multiplication. Understand, this is just literally, you read this as f of x is the way that you read this notation here, and we'll explore that a little bit more later. All right, so let's look at this first graph here. Okay, first of all, is this a function? So we know that each input can only go with one output, or using this new language over here, each x can go with only one y. So if I take this x right here, I can follow it up and see that it goes with that y value. If I use this x right here, I can follow it down and see it goes with that one y value. And it's pretty easy to convince yourself here that no matter where you go on the x-axis, there is only one y value that goes with that x value. So we would say, yes, this is a function. No problem. Now the other question is it a one-to-one function? Okay, so a one-to-one function means that if we take a particular y value, it only goes with one x value. Okay, so let's pick out a couple y's. So here's a y value. I follow it over and I see that it goes with this particular x value right here. If I pick this y value, I can see it only goes with this particular x value here. So it looks like it's also true that every y only has one x associated with it. So then that would mean that this is also a one-to-one function. All right, so we can answer yes in both counts on this particular graph. All right, so now let's look at the next one. We've got this horizontal line here. Okay, so if I go to different x values, am I getting just one y value? Well, yeah. And this one's pretty boring because no matter what x value I go to, I'm getting the exact same y value, but that's okay. The rule is, in order to be a function, I just need each x to go with only one y. Now the one-to-one part is a different story. So remember, with one-to-one, what we say is, does any y value that shows up on the graph have only one x value associated with it? Okay, now lots of y values have no x values at all, right? If I draw a little mark right here, no matter where I go in this direction, or where I go in this direction, I'm never going to hit an x value. Okay, but of course if I go right here to whatever this y value is, I can see that there are lots, in fact infinitely many x values that go with that particular y value, so then we would say it is not one-to-one. All right, let's do two more examples here. All right, so here, just determining if this is a function, let's go to this x value right here. If I go up here, I see that there's a y value associated with this particular x value up here, but then there's also another one down here. So what I have is I have an x value or an input giving me two different outputs. Okay, right now this item at the grocery store is spitting out two different prices. Okay, so here we would simply say this is not a function. Okay, and if it's not a function, then we don't even address the idea of it being a one-to-one function, because obviously it can't be a function at all. All right, but let's look at this one over here. Here we pick this x value. Looks like it has one y value here. We pick this x value. It has one y value there. Pick the x value at 0. It's got a y value of 0, but still only one y value. So it looks good for the idea of a function. Okay. How about one-to-one? Well, like our horizontal line on the last page, I can find y values for which I've got multiple x's that go along with it, right? Two different x's go with this y value, two different x's go with this y value, so we would say it is not one-to-one. Now, the way in which I just went through and addressed these is kind of actually hints at an easier way to think it through. So, I don't know why I have that little spike there, but we can ignore that. If I look at what I've done, I determined that this circle here was not a function, right? And here I determined this was not one-to-one. Notice how the picture that got drawn when I decided it was not a function was I ended up with a vertical line, right? And that vertical line came from the fact that I went up to this y and down to this y. And over here, when I decided this was not one-to-one, I drew a horizontal line, right? So I went to a y value, drew a horizontal line, and I hit two different x values. Okay, so we can really boil this down to a nice easy rule. We have the vertical line test to decide if something's a function, and the horizontal line test to decide if it's a one-to-one function. So the vertical line test just says, if you draw a vertical line, and that vertical line only ever hits the graph once, then it's a function. The horizontal line test says, draw a bunch of horizontal lines. If those horizontal lines only hit the graph once, it's one-to-one. And if either of those tests fail, then of course it's not a function in the vertical line case, and it's not a one-to-one function in the horizontal line case. Okay, so the other way to look at this circle would just be to say, hey, look at this, I'm drawing vertical lines, and I'm hitting my graph more than once, so immediately I know it's not a function. Okay, and then similarly with my parabola here, I'm drawing a bunch of horizontal lines, and so it's hitting twice, so it's not a one-to-one function. Okay, and I can go back to our previous page here. Okay, why is it that this first one is both a function and one-to-one? Because as I imagine vertical lines being drawn, it only hits this line one time. And similarly, when I look at horizontal lines being drawn, it still only hits the line one time, and so it satisfies both the vertical line test and the horizontal line test, and that's why I was able to say it's both a function and it's a one-to-one function. So now we're going to take a look at the same type of examples where we're trying to determine if we have a function or not, and then if it's a function, is it one-to-one or not. But this time our proposed functions will be in the context of tables, and it works the same way where we've still got our x values or inputs listed and our y values or outputs, but they're just listed in a table here instead of displayed on a graph. All right, so all we really have to do here to determine if it's a function is to say, does each input go to only one output? All right, well, I can see right here that there are 5 different inputs here, and they all go to different outputs, so clearly we have a function. And then to check if it's one-to-one, does any outputs have more than one input that it goes with? Well, again, 5 different outputs here, all going to different inputs, so that means it's also a one-to-one function. All right, now in example 3, we look through here and we got to be careful. Notice that 3 is listed twice, right? So we've got 3, the input of 3 going to an output of 1, but then we also have the input of 3 going to an output of 11. Okay, so or another way to illustrate this would be to say we've got this, you know, maybe function, right? This thing, this supposed machine that's supposed to be doing certain things with inputs. We're sending 3 into it, but the machine's confused, right? The machine doesn't know whether to turn it into a 1 or turn it into an 11, right? And that's a big problem. And so because the machine can't figure out what to do with it, we cannot basically give this machine the okay, or we can't call it a function. So this is not a function. And when we've determined it's not a function, we're not even going to bother with the question of one-to-one. All right, so this next example, same thing. Let's look through our inputs here. We've got -2, 2, 4, 8, 14. So no repeats there, and they're all going to this to different these or all these various y values. So each x is only going to one y. So that is definitely a function. But what we do see here is that the output of 3 is listed twice, and it goes back to 2 different x values, right? Now that's okay, right? It's still a function, but it's not a one-to-one function, right? It's not a one-to-one function. So to use our little illustration that I used on the last one, right? We've got this machine here, and we know that when the machine outputs a 3, it could have come from 2 different things. It could have come from a 2, or it could have come from a 4. But again, that's okay though, right? It's okay that this output of 3 came from 2 different things. Again, think of that like the grocery store analogy. Is it okay for 2 different items to cost the same price? Sure, that's fine. But it's just not a one-to-one function. All right, and then lastly here, we're checking, and we got the same problem again that we had in example number 3. We've got the number 1 going to 2 different outputs, and we just can't have that, right? So we're sending 1 in, but the machine's confused. It doesn't know whether to spit out a 3 or a 6, so that means it is not a function. All right, the last thing we want to do here is start to put this idea of a function into some notation, and I kind of described this earlier, but I'll kind of formalize it here, and then also put it in some sort of application context. So we're always going to have this idea of the output is always going to equal this idea of f of the input. That's going to be our notation, okay? And I've already introduced this idea that, hey, a lot of times we like to use y as the output. So what we're saying is that y is equal to f of the input, which our typical input that we like to use is x, okay? So y is equal to f of x, and again, this is not multiplication. This is just the notation that we're going to use. Okay. Now, of course, we don't have to use F. We don't have to use X. We don't have to use Y. We don't have to use any of that. They're just letters, and we can interchange them. But this is the structure of the notation that we're going to use. Okay. And to kind of help us get a handle on this, let's look at this example. It says a hotel chain charges $75 each night for the first 2 nights and $50 for each additional night stay. If the function c of x gives the cost of a stay as a function of the number of nights one stays, what does c of 5 equals 300 tell us? Now, you may feel real comfortable writing a sentence immediately as to what that means, but let me kind of break this down a little bit using the diagram we've kind of been using here. So we've got this function c, okay? C, it's a function of x, right? And x is the number of nights that you stay. So what we're doing is we're taking x, which is the number of nights. We're sending it into C, and then it comes out as the output c of x, which we know is the cost of spending X nights at the motel. Okay, so I think this diagram is really helpful really to envision what are we inputting and what is being output. So when they say c of 5 is equal to 300, we know that this is x, right? Or the number of nights. And so then, since c of x is the cost, when we say c of 5 equals 300, we know 300 is the cost. Okay, so putting all this together, we can see 5 is the number of nights, 300 is the cost, so we can say that it costs $300 for 5 nights. All right. Now, we could have set up an equation for this, and of course we'll spend a lot of time working with equations. It wasn't necessary here because they gave us the answer, but I think it's maybe kind of satisfying to just really quickly look back at the information they gave. It said that the chain charges $75 each night for the first 2 nights and $50 for each additional night stay. So when we're calculating, I guess I don't need this, but when we're calculating this, first 2 nights are going to be $75, right? So 2 times 75. And then those last 3 nights of the 5 are going to be 50. So we have 150 there and 150 there. And so putting all that together, of course, is going to give us that $300 that they were talking about.